Welcome. This is John Metz, a meteorologist with the National Weather Service Forecast Office in Corpus Christi, Texas, bringing you hurricane waves. Wave growth over the open water is dependent on three factors, from wind speed to wind duration and wind fetch. Without wind, seas will be calm. But once the wind begins to blow across the ocean's surface, waves are generated. The top of a wave is known as the wave crest, and the bottom of the wave is known as the wave trough. The distance between the crest and the trough is known as the wave height. Wave heights in an average hurricane can be 25 to 50 feet high. Wave period is the amount of time elapsed from one wave crest to the next. Wave periods in an average hurricane can be 14 to 16 seconds. Waves are measured by buoys. There are two types of buoys, a 3-meter discus buoy and a 10-meter discus buoy. The buoys measure significant wave heights. Significant wave height is calculated as the average of the highest 1/3 of all the wave heights during the 20-minute sampling period. Buoys do not measure maximum wave height. However, statistically, maximum wave heights are around 1.9 times the significant wave height. There are half a dozen buoys located in the northwest Gulf of Mexico, some in deep water and some right off the coast. Live information can be found from each of these buoys on our website. This is an example of buoy 42020, 45 miles southeast of Port Aransas. The following information can be found on the website, from wind direction to wind speed, wind gusts, wave height, and wave period, among other parameters. As you scroll down the page, information can be found from this buoy over the last 24 hours. How hurricanes make waves. Hurricane-generated waves are dependent on wind speed, wind duration, and wind fetch. Assuming a forward motion, the wind fetch is identified as this area in the right front quadrant of a hurricane. The waves then propagate away from this area in this fashion. The largest waves that have been observed along the Texas coast typically originate from hurricanes that move into the central or eastern Gulf of Mexico. This NOAA Wave Watch model simulation depicts the waves from Hurricane Katrina. The right front quadrant of the hurricane produced wave heights in excess of 50 feet according to the model, and 10 to 13 feet in the northwest Gulf of Mexico, which was slightly underestimated. Observed values from buoys indicated the waves reached 55.5 feet in the northeast quadrant of Hurricane Katrina and 13 to 19 feet in the northwest Gulf of Mexico. These are significant wave heights. The highest measured significant wave height from Katrina was 55.5 feet on August 29th, measured from a NOAA buoy located 64 miles south of Dauphin Island, Alabama. This is a graphic that illustrates the 55.5-foot wave crest from Hurricane Katrina. The previous record was set from Hurricane Ivan back in September of 2004 of 52 foot. The NOAA Wave Watch model also simulates wave periods. This simulation from Hurricane Katrina shows the very long period waves that propagated west into the western Gulf of Mexico. Waves travel at a speed of 1.5 times the wave period in deep water. For example, a 20-second period wave moves at a speed of 30 knots, but they will decay to a lower wave height and longer period as they travel. For example, swells generated from a storm in the far eastern Gulf take about 36 hours to arrive at the Texas coast. So if a hurricane produced 40-foot waves with 13-second periods in the eastern Gulf, it would decay to 21-foot waves with 16-second periods in the western Gulf. A storm located near the Yucatan Channel would take about 30 hours for the waves to propagate to the Texas coast. Hurricanes in the northwest Caribbean Sea can generate waves that impact the Texas coast before the storm even enters the Gulf of Mexico. These swells are usually dampened after passing through the relatively narrow Yucatan Channel. On the morning of September 13th of 2004, 3 to 5 foot waves began to arrive along the Texas coast. Hurricane Ivan, a Category 5 storm, was still in the northwest Caribbean Sea. These initial swells were likely generated well east in the Caribbean Sea near Jamaica, where Ivan had produced 130-knot maximum sustained winds a few days earlier. This demonstrates the ability of some swell energy to propagate through the channel and into the Gulf of Mexico. Here's a simulation from Hurricane Ivan, illustrating the waves propagating away from the storm and into the northwest Gulf. Swells generated by Ivan measured 11 feet and 16 feet respectively along the Texas coast from the NOAA buoys. In September of 2005, Hurricane Rita produced wave heights near 20 feet at our Texas coastal buoys. And on September 22nd of 1999, Hurricane Brett produced significant wave heights of 27 feet at our nearshore buoys. This may be the highest record from a NOAA buoy in the northwest Gulf since we've been keeping records. I'm John Metz. Thank you for watching.